Just in previous lecture, we have seen that we are discuss about the geometrical interpretations, geometrical intuitions of the SVM. Now, in this lecture, we are going to discuss about the mathematical formulations of the SVM, and simply here we are discuss about the hard margin SVM, mathematical formulations of the hard margin SVM. And in next lecture, we are going to discuss the soft margin SVM. So let's see what is hard margin SVM and what is soft margin SVM. So just I am limiting my this lecture about the hard margin SVM. Okay, let's see step by step. So if you just remember previous lecture, here in geometrical intuitions we have discussed that, and here our pi is our margin, pi is our plane, that is we call pi, that is our optimal plane, and here we are interested to maximizing our margin. So our main objective is or main motto is we want to maximize our margin. Okay, so first redraw the geometrical pictures. I think it will be better for understanding. Just I am using the blue ink for similar for our positive point. So this is simply our pi plus plane. Okay, if you just remember, we have taken our pi equations of this point. Just first draw this, then I am discuss one by one. And I am just using the red color for our negative point. Okay, and this is our pi minus, and I have using the white color for our optimal plane, for our main optimal plane. This is our main optimal. Okay, and our margin distance is this one is our margin distance. Okay, that we call our d, that is equals to margin. Okay, and in SVM we are interested to maximizing this margin. Let's start. I am denoting some point. I am denoting these are our support vectors. Here I am taking two support vectors, and this is our non-support vectors. Okay, so and I denoted this is our positive points, and for positive points for yi, that is our this is equals to +1. For all positive points our yi is equals to +1. Similarly, for negative points we are using this, simply this is our negative points, and these negative points is also support vectors, and these are these red ink, the non-support vector negative points, and this red ink that is our negative points, and for red ink our here yi is equals to -1. I think these pictures also we have drawn in when we are discussing about the geometric intuitions. And so in geometric intuitions, if you just remember, this is our pi plane, and we have taken the equations of the pi plane is equals to w transpose xi plus b is equals to 0, and the equations of the pi plus plane, that is the plane which touches the positive vectors and parallel to our original plane. Okay, this is the parallel to our original plane, and it is the first plane which touches our positive points. Okay, so and we see that these equations, and we've taken that these equations is equals to y plus 1 equals to +1s. So let's just bear with me why I am taking these equals to +1s. I am discuss everything step by step, but just patience with. And similarly for negative points, this is our negative plane, and this we called pi minus, and this is our first plane which touches the negative point first, and it is parallel to our pi plane. And these equations we have seen that these equations is plus b is equals to minus 1. Okay, till now we have seen in previous lecture. And now our main auto is we are interested to find this margin, and at the end of the day we have to maximize this margin. So how to find this margin, this is the main task. So suppose let's draw another picture. Suppose let's draw, I'm here just using the simply plane. Suppose let's take this is our pi plus plane, and let's take this is our pi minus plane. Okay, and the distance between these two planes is, let's take d, perpendicular distance that we call perpendicular distance that we d, and simply this is our margin. And now we interested to find this d. So let's take suppose let's take this is one our support vectors. This is our support vectors and lie it on here, and we call this support vectors is equals to x1. And one support vector, suppose let's take is here, that is negative support vectors, and lie in on here, and x2 we denoted this x2. And what is the equations of the pi plus plane? W transpose xi plus b is equals to plus 1. And what is the equations of the pi minus plane? W transpose xi plus b is equals to minus 1. And simply if you just think that we are interested to find the difference of these 2 points, that is the distance. So what will be the distance? So simple distance is the difference of the modulus value. Simple this one, x1 minus x2, this is the absolute value of this difference of these two vectors will be the simple distance between these two vectors. And simple we know that norm module absolute value of x1 minus x2 is equals to same as norm of x2 minus x1. So for norm we here sign does not matter, so both the things are same. So now just so x1 is lie on the pi plus plane. Since it is lie on the pi plus plane, it satisfies these equations. So let's write down, it will be x1 plus b is equals to 1. Similarly, our x2 point also lie on pi minus plane, and it is also satisfying this plane. Now what will be if we just subtract these two vectors, what will be our answer? Now I am going to just subtract these two vectors. So these two terms will be cancelled out, and just we are taking common w transpose, and what will be this? x1 minus x2, this is simple is equals to, it will be plus sign plus 2. Now if you just remember in geometrical intuitions, here we have called that here it is the, in this plane w is the normal vector. Okay, and since this pi plus plane and pi minus plane parallel to our pi plane, so directions of the w will be same here, and w is also perpendicular to pi plus as well as w is also perpendicular to pi minus. Okay, I think till now it is clear all of you. And we declare that our w is not a normal vector, it's not a unit vector, and it is not a unit vector, it is simply normal to our plane pi. Since it is not a unit vector, so we call w transpose w not is equals to 1, or implies simply if we take the L2 norm of w, simply it is not is equals to 1. Okay, simply I have denoted L2 norm here. Okay, so simple, just if you take the norm of w, we have seen that Norm of W transpose is equals to what? And it is the simple definitions. Hence, norm of W transpose is equals to norm of W. So this thing will be norm of W, and norm of absolute value of x1 minus x2, and norm of 2 is same to. So simply what will be our absolute value? X1 minus x2. This will be 2 minus norm of W. I think, and simply this is, we called it as our margin. This is our called it margin, and this will be our D actually. This is actually our D. Okay, this is our D. So what we will get? G is equals to, we get that our margin is equals to 2 by norm of W. Okay, so just we are writing this thing again. So here we got that our margin is equals to D. This is simple, 2 by norm of W. I think how we will get the value of D, this thing is clear all of you. Okay, if you just if you don't understand till now, I request you please pause this video and please start from beginning. I think then it will be clear. Now what will be our optimal equations? Now simply we are just interested to maximizing our margin. So we are interested to maximizing this D value. So now what will be our main equations? So we are interested to find the optimal W star and optimal B star, that from where that will happen, that will occur from these equations. So simply that will occur from arc max of all W and B, norm of W. Okay, and also there have some constant, as that there have some constant. Okay, there will be have some constants, and now I am going to how to find this constant. Now I am going to this part. So till now this, I think this thing is okay. So now coming to this part, how we will calculate this constant part, how we will calculate this thing. So just I am redraw these pictures for clear visualization. What will be the conditions? I am just redraw this picture again. So this will be our I plus plane. Okay. This is our I minus plane, and this plane color will be what? Color will be, just a minute. I'm just removing this. I'm read that again. Simple. This is our pi plus plane. This is our pi minus plane, and now I want to do the main plane. This will be our main plane. This is our main plane, and what be our equations? The equations of the pi plus plane, simply W transpose xi plus b is equals to 1, and the equations of our pi plane is W transpose xi plus b is equals to 0, and equations of our phi minus plane is W transpose xi plus b is equals to -1. Simple, we have seen this thing. And now taking our support positive vectors, and let's take, so this is our, this point, this is bluing point, this is our positive points. I'm reading things again, so if you are not interested, please omit me, please just omit this thing. And here yi equals to +1, and for rating this is taken your negative points, and here our yi is equals to -1. Okay, now I am taking the support vectors of our negative points, and this is our non-support vector points. Similarly, for non-support vector positive point, this one, and this our support vector positive point. This is our support vector negative points, this is our support vector positive points. These are our non-support vector positive points. So now the main thing is that here we have to find the value of, as some, just if you remember the logistic regressions, here we have not taken the intercept term, so the equations of the plane, there we got the w, some w term for simple xi, and we are simply multiply the value of yi. The same concept is also applicable here. So here if you just taken this point, just simple, I am writing this thing one side by side. Okay, just I am using the yellowing here. So now case 1. So first I am taking the case 1, and in case 1 we are just considering first for support vectors. Support vectors. In case 1 we are simply just considering the support vector, means these vectors, these vectors, these vectors, and also these vectors. These 4 vectors now I am considering. So if you just see, the first I am considering this positive guy, case 1. So simply this equals half case, that is 1.1, half case 1. So positive, so positive point for support vectors and positive point. So just see this. So here what will be our, now I am interested to calculate yi w transpose xi plus p. Okay, we are now interested this part, related to this part. So what will be our equations of yi here? So here if you just see here, yi for all positive points is equals to +1. So what is our yi? So yi is equals to +1, and this point, these support vectors lie on the plane, and or simple one thing here, what will be the directions of our w? This is the main thing. This is the directions of our w. This is the directions of our w. Simply here directions of our, and w, but w simply here w is not a unit vector. Just remember this thing, w is the perpendicular to our plane, but it is not a unit vector. So now what, for support vectors this value will be what? This value will be +1. From these equations we got it. This value, sorry, I'm taking, this value will be, so value will be +1 for support vector. So final value will be +1. Now let's consider half case 1.2 on negative support vectors. Here I am just considering here negative support vectors. So for negative support vectors here, negative one. So what will be our, now here what will w transpose xi plus b, what will be now the equations? What will be the our value of yi, w transpose xi plus b? So here yi is simple, for all negative points yi is -1. Just I am taking y is equals to -1 into this value for negative support vectors. This value is simple from this equation, from pi minus equations we got it. W transpose xi plus b is equals to -1. So simple, this value will be +1. So if you just see our case 1 only I'm just seeing case 1, then for support vectors positive and negative points, that we multiply that yi into x, W transpose xi plus b is +1. Okay, this is our case 1. Now let's consider the case 2. Just first see this point. Okay, let's consider case 2 now. Yeah, okay. Case 2 simple. For here we are now considering the non-support vector. Okay, for now I'm considering the for non-support vectors. So in a non-support vectors also we have two subcases. So now first consider subcases. Okay, subcase 2.1. So subcase 2.1 will be what? For same previous one. So here I am taking the non-support vectors for positive points only. So here I am just writing positive point. So now what will be the value here? So if you just consider these non-support vector points, these points, so what will be the value? W transpose. So here what will be the value of these points for all non-support vector points? So W transpose, just if you calculate it, W transpose x1 plus b, so directions of the W is the same directions of the point from the plane pi plus, okay. So the directions of the point is the same directions of the W from the plane pi plus. So this value will be positive, and also this value will be greater than 1, because this point, from this point, this value is +1, and this is a simple trick. This value will be positive, like greater than +1. Sure. So if we just calculate it here, yi W transpose xi plus b for positive non-support vectors, then this value will be yi is no problem +1, but this value is equals to our greater than +1. Okay, greater than +1. So simple, this if you multiply this value, so it will be greater than 1. So simple. So this value will be greater than value. So just we are simplifying this. Okay, so I think this concept is clear. For non-support vectors, positive points yi x W transpose xi plus value plus b will also greater than 1. Now we consider the subcase 2. Subcase 2.2. So what will be the subcase 2.2? So this I am taking here, this is for negative point, and negative points as well as it is non-support vectors. So I am considering here these points, okay, non-support vector negative point. So now we are interested to calculate it here, W transpose xi plus b. So for these points, for these guys, what will be the value of W transpose xi plus b? So just see this thing. So directions of the W will what? Opposite directions of the point, this point, opposite direction from this point, and this point is lie on the this point is lie opposite directions from our plane pi minus, okay. So just I'm repeating this thing. So here our directions of the W is the opposite directions of this point from the plane pi minus. So this value will absolutely will be minus 1, less than minus 1. This value, obviously this value w transpose xi plus b, this value will be obviously less than minus 1. Just if you just forgot this, please go to the logistic regression chapter and just see the geometric intuitions. I think then I am discuss everything step by step. Okay, just revisit this lecture, then you can, then your concept I think will be clear more. Simple here, directions of the w is the opposite directions of the point from the plane pi minus, so this value will be less than minus 1. So now if we are if we calculated yi w transpose xi plus b, then this value will be what? This yi is negative, it is surely negative for all points, and this value is less than minus 1. So if you just calculated this thing, this value will be greater than. So I think you are all confused how it happened. So let's take an example. I think then it will be all clear, all of you. Suppose let's take, I am considering this, let's take, I am considering, and the distance, let's take some, there's some distance, let's take this distance, it's 5. So from in this point, what will be the value of? So this will be minus 5. Those directions of the w and the directions of this point, opposite directions from our plane pi minus. So these equations will be this one. So if these equations will be this one, if I now have interest to calculate, if I calculate it now, yi w transpose xi plus b, it will be what? It will be minus 1 into minus 5. So simply it will be plus 5, and just see this thing, it is obviously greater than 1, obviously. So I think this case sub case 2.2 also clear, all of you. Okay, now I'm just simplifying this. Clearly I'm writing this thing. So if you just visualize these two things, for support vectors positive and negative points, we got w transpose xi plus b is equals to 1, and for non-support vectors positive as well as for negative, we got yi w transpose xi plus b greater than 1. So this concept we are using in constant part. Okay, let's write. So in our now equations will be w star, our main mathematical constant equations, optimal constant equations will be, we are interested to calculate it, arcmax of by norm of w such that we have yi w transpose xi plus b equals to 1. So this will be happen for all xi. If you just see, this is not a single constant. If we have a number, if we have a number of data points in D train, if we have the number of data points in D train, number of points, if n, then this thing, this will be, we got the n equations, such kind of n equations. So here we got the n constant. Here we got n constant. Okay, I think clear this thing. Now just if you see just thing, you can arise one question, sir, in real world here the situations we are taking, it is almost linearly separable, or simply here I am taking the linearly separable data, here I am not using any outliers or any such kind of misclassified data. But if you see in real world data, data always there have always the data that is misclassified, but here I am just taking the simply all the data are properly classified. Okay, so in last lecture we are see if how we control this kind of outliers, this kind of misclassified data in these situations. So if here the main from this optimization equations, from this optimization constant equations, our main assumptions will be this data is always linearly separable, or this data is almost linearly separable. Almost linearly separable means what? If we have one or two outliers, if we have simple, if we have these outliers, these outliers, if we have one or two outliers, that will be not matter. Okay, so in these situations it is almost linearly separable, or if it is linearly separable, then this formula works properly. So our main assumption is that here for these equations, our main assumption is, so from this equation our main assumptions is our data is linearly separable, or it is almost linearly separable. If our data set is linearly separable, if or it is almost linearly separable, means if we have a less number of outliers, if we have two or three outliers, then it is okay. So in these situations we call this data is almost linearly separable, then this formula will work properly. Okay, then this formula is work properly. So this kind of mathematic of SVM, this kind of SVM, we call this is our hard margin SVM. This is our hard margin SVM. Because of simple this thing, if our data set is linearly separable or it is almost linearly separable, then our data, then this kind of optimization problem is called hard margin. Okay, I think till now all the concept of hard margin SVM is clear, all of you. Simple, it is just extension of simple extensions of logistic regression. Okay, SVM is the simple extension of logistic. Okay, nothing else. Okay, some. Okay, if you just, if you don't till now, if you don't understand this concept, please revisit this. I think then it will be clear. Okay, so in next lecture we will see the soft margin SVM.